I cannot overstate how much I appreciate the work that these guys are doing for us and for everybody, as well as the time they took out of their day to talk to me. A lot of it is very technical because they are developers, but I encourage you to stick with it because there's a lot of really interesting, at least a lot of really interesting information to me. I hope you guys find it very interesting as well. Anyways, I hope you enjoy it, and I cannot wait to see the future of these things.
Hello, everybody. You guys are so. First off, tell me who you guys are. So, Kalyn, I know Kalyn is one of the lead developers of ButterFlight at this point, and then Tim, what's your role?
So, Helio, um, we're Kalyn, myself, and Sean, a friend of ours, is principal, and that's my son. Sorry. Yeah. We're all software engineers. I've been a software engineer for the last decade, but for the last few years at General Motors. I used to work at Microsoft, been a bunch of different places. Yeah, and through a bunch of very strange events, I ended up meeting Kalyn, and a friend of mine that I work with, GM, who's a math genius and also a software engineer. We just sort of teamed up, and everything fell into place, kind of almost in a surreal way.
Very interesting. And then Chris?
Yeah, so I'm also a software engineer. Probably been doing this I've been doing it professionally for 10 years now, about the same as Tim over here. Worked on mobile, mostly iOS devices, doing a lot of low-level stuff. Also, worked at a few startups, done some really big data sciencey stuff and some back-end stuff. So I'm kind of a jack of all trades when it comes to software engineering.
Wow.
And yeah, so I've been not really working too much, but kind of with Kalyn since I guess right towards the end of his RF1 tenure, before he gave up Preston. I helped him out with a little bit of code in RaceFlight 1, refactoring a little bit of the some of the smart port telemetry menus, and now just working on ButterFlight. So myself and Lucas, or Loose Transistor, we kind of decided to go ahead and fork BetaFlight and change it up and make things different.
So yeah, Lucas wasn't able to make it. He was unavailable at this time. He's another developer, right?
Yeah. So Lucas is also he's got a background in software engineering as well. I don't want to speak too much towards his, but I know he's focused a lot more on front end development, whereas most of my experience comes from back end and low level development.
You sound like a very key player for a future group. Okay, so where did the decision to fork BetaFlight come? Like I know that Kalyn started contributing to BetaFlight and started testing his Kalman filters on BetaFlight, but then what happened that you guys decided to fork Beta? Like, how did the fork come about? Was it always a plan?
I don't think it was always a plan. So I guess a little bit of the backstory, and I know Lucas went over a little bit of this on a different podcast as well, but I can kind of do a short TLDR version. As you know, Kalyn added the fast Kalman filter to BetaFlight. That was merged and accepted. And the guys over at BetaFlight did some mathematical analysis and said, hey, this looks similar to another kind of filter we could do called a biquad RC plus FIR2. And ultimately, they just blocked the Kalman filter from being used in lieu of that one. Myself, Loose Transistor, a lot of other pilots who test flew the Kalman build specifically, we couldn't get the same tune out of the newer filter. Reasonably so. That's a brand new filter they added to BetaFlight. The fast Kalman filter is a little more tested in the air. Whether it be because like the tuning window is different or whatever, I'm very used to tuning the Kalman filter. I've flown RaceFlight 1 most of the time I've been flying, so that was much easier to tune, and the other one just couldn't get it done right. I even ran So this is one of the issues I actually raised. Is most of the experimentation, most of the code they were comparing was transcribed code. Essentially, it was translated into MATLAB or Octave code to compare it. And I'm not a filter guy. Kalyn's the filter guy here. Sean probably could also go way more into the math behind it. I'm a software engineer, so the one thing I always want to see is I want to see unit tests. I want to see a test of the code that you are putting into production as a small unit to verify input output is what's expected. And that's the way I went about it. I kind of threw up I wrote a single unit test that ran through both filters with what were supposed to be the same tuning values, and I just couldn't get the same output from both of them. So rather than try to say, hey, one's better than the other, this one's better, that one's better, I actually don't know. I'm not the person to say that at all. I'm not even going to say which one's subjectively better in terms of like flight characteristics. I just said, hey, can we make it a command line option so that people can pick and use whichever, and we can get more data. Unfortunately, they didn't want to pull that in because of the feature freeze on BetaFlight 3.3, which was kind of trivial because it was just a command line option for code that was already in the code base. So we just said, hey, let's fork it for now, because there are literally hundreds of people asking. I can count at least 50 people on FPV chat that were asking myself and Loose Transistor for the hex files for the fast Kalyn builds.
Yeah.
And it's not like it was removed from BetaFlight. It was just made inaccessible to normal users. It was perfectly accessible to anyone who could pull down the code and compile it themselves, but that's maybe less than 10% of all FPV pilots. I would even say
of course.
less than 5.
I'll be
becoming less and less. Yeah, exceedingly less, where people don't want to learn and just want to fly.
Yeah, most people don't even want to go through setup, let alone like have to go to GitHub and pull down code.
Yeah. So you said one thing that I'm actually learning right now. So with these filters and just ButterFlight, even on BetaFlight, there are now like a new set of tuning numbers, R and Q and these other things. I don't really want to ask what they do, because I think that you guys are heading towards eliminating them. Is that the case? Like, what's the roadmap for tuning?
On ButterFlight, we don't plan on getting rid of them. BetaFlight, what they're doing is they're moving towards a fixed K filter, which is kind of like a variant of the fast Kalyn, where Q and R are removed and a cutoff frequency is calculated so that K is always fixed. Again, I'm not a math guy. I can't really explain how it works too much. Nonetheless, that's what they're adding in. They're changing on the BetaFlight side. We're actually going to pull that change in as well. So we're going to have the biquad RC plus FIR2, the fast Kalman filter that Kalyn wrote, as well as this updated fixed K Kalman, and that's all going to be provided side by side as options in ButterFlight for any targets that need this sort of filtering. Asterisks.
So if the fixed K doesn't work for one, then you try other ones and try tuning things.
I mean, the ideal is, from my standpoint at least, the idea is, give an A/B test case to users. If we're saying these look the same in MATLAB, in simulations, let's practice. Let's see it in practice. Let's see it in flight. Let's look at logs. Let's make a way to, at least tune them similarly so they should give the same output, and then let's see if that's the effect. But we have to actually test that. We can't just look at a simulation and say, hey, that's sufficient. Testing on real-world data, and again, like I mentioned, testing with production code, the actual code you're shipping, use that to run a test. That's the metric I kind of go by. It's kind of funny actually, because one of the BetaFlight developers mentioned to me is, hey, don't you think, what do you think MATLAB does math different than C? And yeah, actually, there's a lot of cases where that happens, especially when you're doing a lot of compiler optimizations with fast math. Math tends to get skewed a little bit in in actual, real-time code, and it's not exactly as precise as the ideal world wants it to be.
So then, is there like a really concise way to sum up what Q and R do? Like, how can you think about them? Because we've kind of learned PID. What's Q and R?
I will defer to Kalyn for that one.
Yes, give me just 1 second here. Get the actual name of it here, so I don't mix them up.
While he's looking that up, I was just going to say I try to simplify it for everyone. Is Q is trust in your gyro, and then R is your actual error rate. And so
interesting. Wow.
Q, if you think of Q as trust, the higher the number, the more you're going to trust the measurement rather than filter out the measurement. Which is why when you lower Q, you're actually increasing filtering.
Oh wow,
yes,
that's very interesting.
Very good way to look at it, actually. So Q is the process noise covariance, and what that is like exactly what he said. How much do you trust the gyro or not? And R is the measurement noise. How much noise is there in the measurement itself? And that is a measurement of the gyro itself. So basically, what you're telling it when you set Q and R to a certain number is you're telling it there's a certain amount of noise in the system. And the easiest way, what I'm telling people right now to do is set R to 88. And I say that number because that's what I actually calculated as the noise in the 2601 gyro. And it's going to be a little bit different in the other 32 kilohertz gyros, but it's going to be pretty much the same, pretty close. So I tell people to set it to 88 and then adjust Q based on how your quad responds. You tend to want to go higher if it's a clean build, maybe a lighter powered build, and lower if it's a more higher performance build or a noisier build. And that tends to work pretty well. What you do not want to do, in my opinion, is do not treat it like a low-pass filter. This is not a low-pass filter. We're not filtering for a subwoofer here. We're filtering for a quad. And this is an actual motion filter. This is what it's designed to do, so treat it differently.
I have so many questions to ask about this. So, I'm imagining a system in which it could potentially do its own checking and figure out what it should set itself to. Is that a possibility?
Oh, absolutely. In fact, we do have that working, and it's running on the Helio board, actually. In the IMUF,
Awesome.
It's currently running in there.
Okay, before we continue, I have a quick. Well, go ahead.
Oh, what was I saying? So yeah, absolutely. The plan is to go completely automated, and
even with PID, even with the PIDs, all the PIDs.
What I want to do is get rid of the PID controller. I think it's archaic. Do you know that the PID controller was invented in the 1800s?
Yes, I do.
It's ridiculous that we're still using it.
Yeah.
The problem with those things is that it's just computationally expensive, and you couldn't do that and filter and do everything all on a single chip.
Exactly.
So because this is probably the single most exciting thing to hear that there's actually development towards, do we have a potential estimation of when we might see something like this?
Oh man, that is so hard to say.
Like 1 year, 2 years, 6 months?
Less than 2 years, I would definitely think.
Okay, that's
hopefully
good.
this year, but I don't know. I have no clue how long that's going to actually take to get everything completely automated. The filtering we're really close on. We're very close on. The next step is the motion controller, and once the filtering is solid, I think that's going to kind of fall into place.
What's the motion controller?
So a PID controller is the motion controller. It controls motion, literally. And it's not the only type you can have. One very popular one is called LQR, a linear quadratic regulator. And that's basically just a Kalman filter that outputs directly to your actuators, your motors. It's not, it doesn't go through something else. It just outputs directly. It's extended from the filter. Easiest way to think of it.
And that is what, that's what NASA uses, correct?
Yes, NASA's been using the Kalyn. They used the Kalyn filter on Apollo. They're using it now. Aerospace companies all over are using the Kalyn
Wait,
filter.
how are they using that on Apollo? Like, they didn't even have any computers.
They definitely they have the Apollo guidance computer, and I don't know if
Oh,
they
yeah.
use the Kalyn filter in it specifically, but they definitely used the Kalyn filter when they were planning to get to the moon.
Yeah,
Although they did actually use a PID controller on the lunar lander, so they use both.
So it's good enough to get to the moon. It's good enough for our quads.
I guess.
Okay. So then the other very, very important key question that I've personally been wondering, and I have had a lot of people ask me as well, and I had nothing to say, is so the most distinctly unique thing about ButterFlight the first time I flew it was that there was just this sense of smoothness when I flew, and it was eerie because from BetaFlight I know what my fingers are doing because I can see my pulse through the FPV feed, but all of a sudden I don't see that anymore with ButterFlight, and it's amazing. Like, how connected is tuning to the actual stick input control?
It's the same thing basically right now. The way a PID controller works is your fingers directly control the error rate in the controller, and that's
Mhm.
what tells the quad to move. So
So,
it's
so like,
it's
so,
the same thing.
so essentially, having a better tune on the quad, more control over the quad's movements, is in essence what's giving you the improved control.
Well, having more accurate gyro readings is what's giving the PID controller. It's making it work better, essentially.
More info to work with. Okay.
Yeah, because it's the
Exactly.
the PID controller is working off of two things essentially. It's got a set point and a measurement. The set point is where it needs to be, and the measurement is how it figures out where it needs to be relative to where it is. It's going, oh, I need to be there, but I'm here, so let me, change this much. And that's what the PID values actually do. You're doing a proportion of the error, integral of accumulated error, and a derivative of all of that shit to soften it out. So that's what a PID controller is doing, is it's just taking the set point and the gyro reading. So if your gyro reading is noisy, it's not giving you accurate data, then you can't expect the PID controller to be able to say, let me correct for the error between where I'm at and where the set point is. So with cleaner data, it can go, yeah, I can more accurately get from where I'm at to where I need to be.
Okay, so what about the sensation of stringing movements together, like the yaw and the pitch or roll? A lot of the times I'll try to do a coordinated roll, and this frame will look all funny because I don't line up my movements exactly. But on ButterFlight, I don't see that tearing of the screen as much. I don't know if I explained that very well. I hope people understand that. Does that make sense?
So inside the fast Kalman filter, what I'm proud of with it is it actually is a two-state filter. It takes the acceleration and calculates it based on the previous state. The state, when I say state, that's where it thinks the quad currently is. That's where it thinks it should be, basically. It projects it forward, it predicts, and then it puts in the gyro data, and it uses it as a kind of a sanity check is how I like to explain it. So the data that your PID controller is getting it basically has a level of sanity check to it that it didn't have before, and that's something that Kalman can do that any other filter any other that we're using currently can do. So I think that's where you're getting some of that. You have more accurate data getting to the PID controller, and that's how it's happening. That's one of the ways it's happening.
So there's no actual filtering or tuning or anything going on with my stick inputs, with my actual stick inputs.
No, nothing that you haven't used before that I'm aware of, at least.
Yeah, so it's all of the set point stuff is still the same. We haven't changed any of that code yet. So any of your RC interpolation, set point transition, all that stuff. That's still the same as BetaFlight.
Yes.
So
We-
then,
we do
that
have-
kind of makes sense.
We do have asterisk some updated D-term filtering that uses set point or doesn't use set point in a different way than BetaFlight, and that's going to be coming out soon. But that is unrelated to the Kalman filter itself.
Oh, that's
Correct.
So then, in essence, it's just the process is getting cleaner information rather than guessing where it needs to go.
Yeah,
And that's
it's getting
Oh.
cleaner information and just a higher resolution of information. So that's one of the reasons to run 32K and why Kalman sees that much of a benefit there versus some of the other filters, at least in my opinion. Again, caveat emptor, I am no mathematician. I just write code.
That's
Yep.
that's
So-
exactly right. Is the faster that Kalman can sample, is the faster or the more accurate its predictions become, and the more it can actually smooth out that jittery gyro information, because the gyros are cheap, right? They're $1 gyros. They use lasers, and we are punching 170 amps through this tiny little PCB, creating a ton of electrical noise, and it causes that sort of problem.
Yeah.
So the faster you can sample Kalman, the faster that Kalman can sample the gyro, is the more benefit you're actually going to see.
That's amazing. So there is a rationale for going up to 32K and even past 32K, because I know like even a BMW's anti-lock brake system, it only samples at like 192 hertz. Like it's very slow sampling, and so they don't feel like they need any more. But in this case, it's because of the electrical noise and all the system that requires it. It's not necessarily the movement of the quad in the air. It's just because it's just so noisy and so messy in there, right?
Yeah.
Exactly. You want to be able to take in all the data you can so you can figure out what actually is going on. And, honestly, you could probably, if you had perfectly clean data, 100%, you knew exactly what was going on, you could probably run at 1,000 hertz, no problem. The problem is you just can't do that. It's not possible right now.
Amazing.
Yeah, I mean, I guess an analogy, even though I know Kalyn doesn't like to compare audio to motion, but an analogy I always like to think about is if you've ever heard 8 kilohertz audio, it sounds disgustingly horrible.
Yeah.
That's what your cell phone used to pump out, not MIDI, but the old recorded ringtones at, and it's just horrible. CD quality is 44 kilohertz, and the difference between 8 kilohertz and 44 kilohertz it's a giant leap.
That's
in
a
terms
fantastic analogy.
Yeah,
Yeah, absolutely.
and to kind of, to add on to it, in terms of like audio engineering, if I'm not in a soundproof room, and this is something we can't do with quads, we can't make a soundproof room for quads. But if I'm not recording in a soundproof room, I'm going to have background noise. If I'm in a soundproof room, anything I'm recording is clean. There's no background noise because it's freaking soundproof. But if I'm not, there's background noise. At 8 kilohertz, you can't clean that background noise
Right.
out. At 44K, you can kind of clean it out at 44K. At 192K, which is typically what studios are mastering at, 192 kilohertz, 24-bit audio, you can clean anything out. People clean up old records by doing that. They pull it in, sample it at 192.24, and it makes it super easy to go through and clean up noise because you have a much clearer picture of what the noise is.
By the end, you end up with 44 kilohertz and your CD quality, and you're fine. That's an amazing analogy. That is probably the single best analogy of any of this filtering stuff I've ever heard. That's really incredible. I hope people understand that, because that is amazing.
So the maximum sample rate of that 2601 gyro that we use is actually 8 megahertz, and that's where we want to get to.
8 megahertz? Are you serious?
Correct.
Really?
Ooh, interesting.
Wow, so that's not even close to maxed out. Well, so one thing I really appreciate is that you guys basically told me that it's not my fingers that are screwed up, it was the code that's screwed up. That's why I felt like I was all out of sync. And so, oh wow.
Well, that's one reason. I've always, I've flown RaiBlocks since I started flying 5-inch, which was probably last March or April or so. It's been about a year. And RaiBlocks was just easier to set up, so I went with that. But every time I tried to switch to BetaFlight, it just, it didn't click the same. It didn't feel the same. And feel is something that you can't go around talking to developers about because they're going to tell you to get the fuck out. It's a subjective quality. It's not measurable. It's not quantifiable, but it's definitely something that's different. So, instead of just disregarding it, taking some due diligence to actually try to drill down what is the difference between feel. And that's one of the things when I, flew BetaFlight with the fast Kalyn for the first time, I was like, yeah, this is race flight. What the hell? Like, this is the same feel. What do only now I can get an OSD.
So in regards to feel, something that is, in my opinion, a very big problem right now with quads is the PID controller. And the problem with it is it's so connected to the feel of the quad, and it should not be that way. The PID controller should be completely separate from the feel. Whatever your quad's tune should not interfere with the feel of the quad. Those should be two separate things. And right now, because of the PID controller, that's not the case. We can't do that. In the future, I believe we can.
Yeah, people are making their quads fly like crap in order to get a specific feel out of it, and like Kalyn was saying, it's a scientific methodology, right? Like it's designed to make it do exactly what you tell it to, and then that's where things like expo and rates and those sorts of things come in, so that you can get the feel from just the sticks themselves, and the quad will respond exactly as requested.
Yeah, you should get feel out of stuff like rates, rates expo, and set point transition. The PID controller should always hit the set point perfectly. That's a perfect tune. Is the PID controller perfectly hitting the set point? The feel is really the set point. It's where that's at. That's where the feel comes from. So,
unfortunately, the PID controller, by its design, can never hit the set point. It's the way they're designed, the way they work is they always swing back and forth where they're supposed to be. Think of it like a fuel injection on a car, how they operate, swings back and forth, same deal. Other motion controllers, like what they use in rockets, LQR, stuff like that, can hit it exactly. So that's one of the reasons we want to move to those. Get away from this archaic 1800s technology and get on to something that they're actually working with now to land rockets.
Wow, I honestly cannot even believe these things can fly better than they are. That they have a future of being able to fly better than they do. Like my quad flies so awesome, it's unreal.
You want to blow his mind with Quaternions?
Well, I was going to say, do you know that's exactly what causes propwash, right? Like, propwash isn't the turbulent air making the quad move around in the air. The turbulent air is causing gyro noise. That gyro noise translates into PIDs trying to overcorrect and fight each other, and that's why you get that turbulent oscillation as you settle into that, is because of the PID controller itself and the noise within that gyro not being filtered out, which is why in Kalman it's not trusting the gyro initially and giving that to the PID controller, and that's why you end up getting a smoother feel around corners and dropping into areas where you'd have propwash, stuff like that.
So then, propwash is in essence a misnomer then, because it's from helicopters. It means something kind of different, a little different, not really. It means like recycled air, kind of, isn't it?
Yeah, that's where it happens. And one of the reasons it happens there with quads is because the dynamics of the props, the motors, and how they operate change. A lot of these high-pitched props will actually stall in a hard turn, and when they stall, as you increase power, you decrease thrust, which flips the PID controller on its head, and it just doesn't know how to handle that. So it oscillates back and forth wildly. And you can build a motion controller that can look for that and deal with it properly. Think about like skid control on a car. You hit the brakes and the tires lock up, it's going to slide faster. Well, prop kind of does the same thing in prop wash. Whereas if you have traction control, it's going to actually release the brake to slow you down quicker.
Oh, wow. So
torque, so that you're not spinning.
That's amazing. So then with like BL Heli 32, where you can actually get feedback from the motor, you can actually sense that.
Absolutely, yes.
Yeah,
Holy crap.
That's more data that could be perfectly useful in a motion controller, but it doesn't really fit into the, ye old PID controller.
No, not at all. It won't work. But You can put it through a Kalman filter. There are spots for that.
Holy
You have to make
moly,
'em,
dude! This is like
put 'em there.
this is mind blow. This is nuts.
Oh,
Jeez.
yeah, to blow your mind on the Quaternions. PID control, yeah, pitch, roll, and yaw, right?
Mm-hmm.
Quaternion is 4 dimensions, not 3. It's actually a 4-dimensional shape to represent a 3-dimensional item. And you only have one axis that you need to compute. Not all of them. You just compute one.
Yeah, so
And
I'll give you
Less
I'll give
math.
I'll give you a little
this is like a
TLDR on
tesseract from like one of those Marvel movies, like the tesseract.
Kinda.
Like, what?
Exactly.
Well, think of it like this. Think of it
So
like this.
I mean
It's really,
I
have you ever done like shop class or anything like that, where you have to learn about the Pythagorean theorem, right?
Of
Which
course.
is a squared times b squared equals c squared, right?
Uh-huh.
Very, very basic. Hopefully, everyone has done something. They've heard of this. It's a 3-dimensional Pythagorean theorem, is what it is. It's more complicated, and you use that information to let the quad know where it is relative to gravity, so that
Okay.
it knows where the horizon is.
Whoa. So then there's no need for an accelerometer anymore.
Well,
Well,
you
then
need that.
still use it. Calculate.
yeah, so the gyro and accelerometer are used in combination to calculate quaternions. So I mean the another, if you've ever dealt with imaginary numbers in geometry or
Yeah.
algebra,
Yeah.
quaternions are they're imaginary numbers. They're the same thing. Imaginary numbers are useful for translating a 2D object in a 2D space. So I have 2D object, I want to rotate it or translate it and move it in a 2D space. Imaginary numbers are really useful there. So you just have one imaginary number for the equation to do that. So when you jump up from 2D to a 3D space,
I understand.
the guy that figured out quaternions tried just saying, oh, let me add another. No, it turns out you need 3 imaginary numbers for 3D space to do that same thing. So that's where quaternions come in. They're that imaginary I from geometry / algebra, but in 3D, well, 4D technically, there's 4 dimensions of quaternions for 3-dimensional space.
Holy moly, if people haven't done some level of math, I mean, I've gone through linear algebra, part of linear algebra, and I barely understand that. That's amazing. So this is like straight up theoretical math that you guys are doing to try and get these things to work right.
And aside from the math itself, what getting away from like the technical side of it, what it translates into is a lot of people don't actually understand them, and there's a lot more applications for quaternions inside of what we are doing than I don't think anyone's actually really thought of. And I've sat down with Kalyn and Sean and talked to them a little bit about it and said, are we am I crazy thinking that we can do this with these things? And so I don't want to get too far into that because it is stuff that is part of our intellectual property within the IMF controller, but that is going to really change the game.
Holy crap. Okay, let's move to something else before people's minds melt.
Before we depart, just go YouTube Quaternions and let your head explode.
Okay, so the other question I had was, is there going to be continued collaboration between BetaFlight and ButterFlight? I know that it's a fork, though. The fork means that ButterFlight has to stay open source, right?
Yeah, so ButterFlight isn't going to be completely open source. One of the things we plan on doing in the interim and the short term is trying to keep up to date with all of BetaFlight changes, so it's pretty trivial for us to merge in any of the updates, any bug fixes that they do. At some point in the future where our feature set might diverge and that becomes more complicated because of conflicts when merging, we'll be sure to bring in big fixes or manually pull over small fixes, and so on and so forth. To the same degree, BetaFlight's more than permitted, I guess. Well, it's open source, so they can do whatever they want. But yeah, they're more than welcome, should I say, to kind of pull in some of the changes we make. Some of the initial changes, we forked forward to actually give people options. So, if it comes out and we have data and that says, hey, this is better than that, or then rather than the options going into BetaFlight, then the good thing can go into BetaFlight. So especially too with some of these things that are, I guess, community demanded features. That's another thing that Luce and I kind of want to try to focus on is actually listening to the community by and large. And one of the other first things we kind of launched with was the AKK VTX smart audio fix.
Yeah.
Which so I mean that just fixes it makes it's something I disagree with what BetaFlight did with that, is they fixed the smart audio they quote unquote fixed their bug that they had in it, but that in itself obsoleted a large body of hardware that people already had. And I won't get into the ethical arguments of the company stealing TBS's protocol, even though that protocol is now open source. Nor will I get into the ethical arguments of any of the companies selling whatever TBS might say they're knockoff. I don't want to go down that path. What I will go down the path of is users being affected. Users have hardware, and frankly, if they're buying the cheap AKK VTX, they don't have deep pockets. So basically fucking over their perfectly good hardware just for some moral high ground is really a detrimental thing. We have a lot of people in this community that they scrape whatever cash they can to get parts, and sometimes they're buying clone parts off Banggood. They're buying the shittiest of motors, shittiest of parts, shittiest of frames. But they still want to get out there and fly, and I don't want to be. I personally want to let them fly if they
who are we to tell
have
them
the
no?
stuff to fly. I'm not going to say, hey, save up $50 and go buy a proper Unify or something.
Yeah, that's really the main base argument. At the end of the day, we're all just having fun, so why bother?
Yeah, these are all toys. I don't know why people take it so serious.
So then, a little more serious about it. So you guys do actually have intellectual property, and it's built into the board, and it's built into kind of your future roadmap of your filtering system and the second thing on the board, right?
That's correct. And what we want to do too is we tried to start doing that with BetaFlight, and then things ended up working. And
so hold on, real quick. Let me tell people if they don't know. The Helios board has an F4 and an F3 on board. Both processors are on board, and the F3 is dedicated solely to filtering and gyro management. Is that right?
That's correct. The flight code sees the F3 as if it's a gyro, and sends the flight code all of the pre-filtered information. So we've actually removed in our target all of the filtering, all the gyro filtering code, and left just the D-term because we can't really do much with the D-term at this point. We might be able to in the future, but really what it is because of PID controllers and everything, D ends up creating resonances, and so that's why you'd end up with like hot motors and stuff. But the idea is that as we develop this IP, if there's anything that we can put into ButterFlight and say, hey, this is something that will actually run on a single IMU, and within BetaFlight without or ButterFlight without making it crap the bed, then we want to be able to do that. We want to be able to give that to whoever can run it, because they will at least be able to get a taste of it through ButterFlight, and then if they want the full experience, then they can get a Helio board.
So I know the board also works on BetaFlight though. So does it still get the filtering benefits through BetaFlight?
The what filtering? Sorry.
So the Helios board will work on BetaFlight as well, right?
There's no official target in BetaFlight.
Okay, so then good. So then it will.
That, but there is a version that we have posted. It is part, or it does run BetaFlight, but it's not officially supported by BetaFlight. It's all just stuff that we had internally, and we were going to post that, but then this fork that popped up from Loose Transistor and APOC. It was just sort of an opportunity at the time, and we jumped on it and said, "Hey, let's make this happen," because I think this.
Yeah, it's certainly helped get the Helio shipped faster. That's one of the other issues we were kind of running up against is it's kind of a clusterfuck at the end of February, if you will. And feel free to
Yeah.
beat my speech, but Chinese New Year, everybody's rushing and getting stuff around, and BetaFlight was coming up on the release candidate and the feature freeze, so it made it a little easier to ship the Helio out with ButterFlight because we could do so unencumbered without thinking we're affecting other BetaFlight targets. We can kind of look and see if there's any issues, and we found a few issues here and there that we've resolved, and we probably bound to find a few more. But I think the plan is to like I mentioned before, anything that ButterFlight has, BetaFlight is more than welcome to backport, Helio target included.
Wow. Okay. Okay. So, is the name ButterFlight going to stay? Or is it going to change?
I think that's the. I think it's going to stay. It's gotten some pretty good traction. I think people like it. We like it.
The logo's great. Who designed the logo?
I believe Luce designed the logo, actually.
It's actually, I like all the multiple wings. It really gives you the sensation of smoothness.
Yeah.
It's a nice logo.
Yeah, I believe
I'm assuming
Sinister from FPV Chat, I think, came up with the name. We'd batted around a few before, NanoFlight, Alpha Flight, so on and so forth, but Butter kind of just had a nice ring to it.
So, I'm assuming you guys are going to be changing the configurator going forward at some point, right? Like things will change in the configurator.
So we've already changed some of the configurator things. Obviously, we've changed the branding and some of the themes.
Yeah.
We do have some planned configurator updates towards the settings that we're going to allow as options to users. Obviously, we're going to be getting rid of some of the things that we're axing from ButterFlight. I probably should have mentioned before. So to make things sit on F3 targets, we're getting rid of unnecessary features. We don't want to focus on like every single possible application a flight controller can have, like BetaFlight and CleanFlight does. Nobody's going to be using ButterFlight for a wing. We don't care about servo control. We don't. LED control is something we can do away with. So things like that, we're probably going to get rid of a lot of the nav control unless there's a high demand for it. Just to kind of clean up some room so people on old.
That was my next question: is if there's any chance of having navigation or at least GPS readout or something of that sort for long range stuff.
So I mean, that there is a possibility, but that's going to be based. Again, we're going to base that stuff on kind of community demand.
Mm-hmm.
We're gonna look through code and we're gonna try to get rid of stuff that's largely unused because there's just a lot of old, outdated code in BetaFlight. The nav code is very outdated. It's like it's code copied over from like an old iNav fork, I think, that nobody ever uses.
The mixer.
Yeah, exactly. So I mean, that kind of stuff can just get updated, and as people want to use it. So there's a few people I've seen who are trying to develop a return to home just using GPS, no compass or barometer or anything like that, using just GPS heading, and they're kind of working on stuff that I think that might be something worth having in.
Yeah.
But yeah, we don't need like full navigation control. Like we can more than likely toss drivers for things like barometer and I don't think there are any drivers for airspeed sensors in there, are there? There probably are.
There are actually.
Honestly, if it could be done modular, where you add something like a barometer or navigation or GPS or any of this, and it doesn't interfere with other code like it does now, I don't think it would be a problem to have it in there.
Not at all. Yeah. I mean, if any of you are familiar enough with OpenTX, like OpenTX configurator even lets you kind of custom tailor a build of OpenTX for your radio. You can go in and you can literally checkbox which features you want compiled in to the firmware you flash. I don't think anybody actually uses that except for maybe some people. I used it at one point way back in the day when OpenTX first came out, probably around 2012 or so, when I had my Turnigy 9X and I was flying helicopters with it. So compiled different. You can literally compile your own firmware from the the companion app, which was kind of cool. And
I
it's
did the same thing for the same reason.
Yeah, and it's that's something that we might look towards trying to do. That's a little trickier, but hey, it might be doable. Um, and yeah, so I mean, there's a lot of things we can do, and again, we're going to focus on cleaning up code, getting rid of old code, and adding stuff in the community wants, and adding stuff in that's new, experimental, letting people A/B test things. We will have preferred configurations, but I think giving people the option to go out to the field and test things is a really big driver in actually getting them to learn more about how their quad works and thus actually getting a better flight experience.
Hmm.
Most people I fly with don't even know how to tune their quads.
Jeez, I've been flying for 3 years. I can't tune my freaking quad. Like I gave up. I just waited for you guys to fix it for me.
The Helio did. In our targets, we created 3 sub-targets. There's a stock one, which is hopefully a good baseline, and then there's one that's tuned for race quads, one that's tuned for freestyle quads, and then one that's tuned for the Make Good Special. And, and so we got kind of 4 targets have just different filtering values, presets. Hopefully, you can start with a decent baseline, and if you do want to fine tune it, then you can. But hopefully, you can just plug it in, flash it, go.
Yep. I will say with my Helio, my first build, I had to adjust the filtering a little bit to get that in line, and that's some of the experimentation we did for the testing. But I haven't touched the PIDs, and it flies amazing.
So then the next question I have is, which you guys can definitely say you don't want to answer. Is there any future of firmware for controllers?
For like transmitters?
Transmitters.
Not that I'm aware of. I don't really think there's much of a need.
We've got some ideas.
That's enough. That's great. I would love to see transmitters running something so I don't have to deal with my computer.
Yeah. So I mean, Helio is going to have their things that they're going to do. Mind you, again, Helio and ButterFlight are separate entities. We just happen to be working together because we get along. But yeah, my perspective personally, transmitters do a pretty good job already. I don't really think there's too much room for improvement. I know one of the philosophies Kalyn had on raceflight was why program your transmitter? The flight controller can kind of calibrate all that shit for you. So there's something like I can't stand messing with endpoints on my radio. I always go, even in BetaFlight, and I calibrate it in there. It should be calibrated in there because why not?
Right.
Yep.
And that kind of extends to a lot of things. Like really, the transmitter as it is kind of does a perfect job. The only thing to kind of go after and fix is maybe improving refresh rates, improving latency, and a lot of that mostly comes down to hardware. I know a while back I personally did a lot of latency testing with radios. I've got a lot of radios. I have 2 Tyranni, a Futaba 14 SG. I've got a full-size Crossfire, and I've got a Spectrum DX9. And I did I also have a Turna G9X. That's my old beater radio that I used to fly everything with. But I did latency testing on all of these, except for the Turna G, because I actually don't even use the FlySky module it came with anymore. I don't know where that is. I only used it with like one of those orange DSMX modules, so I didn't bother that one. But I did latency testing for like all of them. Everything's around the same. Crossfire, Spectrum, Futaba, they're all around the same latency. Any of the like 5 millisecond claims are kind of like whatever, drop in the bucket because there's a large amount of variance in what the actual latency is, packet for packet, or depending on when the input signal actually is in the frame of like when the packets are going out and so on and so forth. But yeah, FrSky was like the obvious loser because everyone else comes in around between 10 and 15 milliseconds. Literally every other radio I tested, 10 and 15 milliseconds.
Yeah, FrSky's got a new protocol too now.
FrSky
one wire thing.
The lowest latency from input to like seeing the signal on a flight controller for FrSky that I saw was 27 milliseconds. It was usually around 30 to 40. And actually D8 versus D16 or whatever the 8 channel versus 16 channel, that didn't matter at all. It says, oh yeah, it's 9 milliseconds. It's the difference isn't 9 milliseconds. It's because it's on the order of 30, and it's really a problem with the XJT module. I do want to get my hands on one of the new iXJT modules, which FrSky says that they have they've improved the latency for. I'd like to test that, but I mean, otherwise, yeah, that's my personal stance on radios. It's all good except for latency and refresh rate. If we can improve those two, then we're good.
I used to play Doom 3 on a 200 millisecond ping.
Yeah.
I rocked that crap, man.
Well, I mean, I even did some I did some kind of number crunching, and people are whenever I guess when Crossfire was kind of being hyped up, people were kind of saying, oh yeah, like 10 milliseconds, you can't even notice that, whatever, blah 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 blah. But pump that up to the 20 millisecond difference that FrSky has compared to everyone else. If you look at 20 milliseconds at 80 miles an hour, I think
Right,
that's
yeah.
like
That's what I always say.
you've traveled like 3 to 5
6
feet
feet.
or something. Yeah,
It's like
yeah.
6 feet. I've calculated. Yeah.
And that's a lot. Like
Yeah,
that's
a huge margin.
That's like missing or hitting two race gates almost.
exactly.
It's like being inside a tree or being next to the tree.
Exactly. So I mean, that much time matters, and it kind of goes. People always also mention like human reaction time isn't that fast. Well, I mean, that's because people are comparing a statistic about human reaction time based on purely reactionary tests.
Yeah, right.
There's a difference between reaction and predicted response. Reaction is purely I don't have any knowledge of what's going to happen. It happens. I react. That's reaction time.
Well,
Prediction or predictive response is, I see this thing coming. I can estimate how much time it's going to take me to get there. I know I'm going to need to respond about here. So your reaction time in that scenario is actually much, much, much less.
Yeah, it's. I think the whole latency in the system, including the video and all, it's going to be at least 50 milliseconds before the quad gets any response back from you. Something like that.
That's why I'm actually even going out and testing these newer Foxeer Predator cameras. 15 millisecond latency, bro.
Yeah, no, it's really good. The Eagle is my favorite right now just because the view is beautiful. It's gorgeous. It's completely like looking through a GoPro.
Your brain compensates. If you ever read XKCD, he did a pretty good write-up on throwing things, right? And a strike zone in baseball, the pitcher throwing an 80-mile-an-hour fastball, he has like a 6 millisecond window to actually release the ball, something like that, and then it takes like 13 milliseconds for your brain to actually tell your hand to release that ball. So you have to be telling your brain has to be telling your hand to release it way before it actually has to. And so, when we talk about perception of latency and things like that, like your brain compensates a lot for a lot of those. But you will see a difference because it will feel different. Your muscle memory just becomes different.
Oh, I mean, the latency testing for me was spurned completely after I got Crossfire, and frankly, I had I guess my antennas weren't doing that well. I was getting pretty close range fail-safes with it, but like I was definitely feeling the switch between the 150 hertz and the other. Crossfire will drop when it's got lower signal
of course. Yeah,
a
definitely.
much lower update rate.
Yeah.
So I could feel that switch between the two, and that was kind of me going, hey, let me actually test this out.
Yeah, of course. Okay, so the last question I have is actually a question that's like a mix of all my own testing of things, and I asked this because you guys, like, you write the code and then you go out and see if it actually does what you wrote it to do. So inherently, you guys are also hardware engineers as well, like motors and props and all the other stuff. It's like you have to be in order to get it to work right. Right? Does that make sense?
To some degree. I mean, I don't have much of mechanical engineering background. I took a lot of electrical engineering, and I've learned a lot of electrical engineering. Obviously, inherently, if you're in the RC flying in general, just RC in general, you're going to learn some electrical engineering. Mechanical engineering is something that I'm still at a loss for. and I take a lot of input and advice from other people. Like I personally do not know how to choose the right motor prop combo. Like I'm going to
No, that stuff
kind of fudge
is
that.
not really. Well, but here's my concept. So I primarily fly. I only fly acro, and that's even if I get a chance to fly. And when I try, I've tested tons of props, and when I try different props, I really like the steeper pitch props, just from the way they feel, the amount of like low end throttle aggression that they have, but they lack just the fine-tuned ability of like yaw and turn. Yaw should actually be better if my brain is correct, but it lacks this fine control of when I'm doing like really close proximity. And I feel like it's just a notion that I've gained is that the lower pitch props tend to have more fine control because the props are just spinning faster.
Well, it's also because they're not stalling as easily.
That makes sense too. Now that also makes sense. But my question was, does the flight controller like, is that accurate from a flight controller standpoint? Do the props spinning faster help things improve in terms of feel?
I mean, I think that's in a weird kind of realm there at that point. Because yeah, that really gets into, it's really prop matching. Like you ideally.
So what do you mean? What do you mean by faster though? Because if you're all things considered, you throw on a 4.6 to a 5.2, right? And you're sitting at the same KV, same everything. Your props aren't spinning.
No, I mean you don't need as much. You don't need as much throttle to stay up. So you're flying at a lower throttle range.
And what I've noticed is that the lower pitch props actually have more kind of low end, because what happens is those higher pitch props are made to be spinning even faster. You look at a turbine engine.
Yeah, right.
And those are like crazy steep pitch on a jet engine. But at the same time, the mechanics of those are completely different too. But the same thing applies is that the higher pitch the prop, the higher the RPM it's designed to be efficient at. And so when you get into those lower end ranges, because these quads are so freaking light, it really doesn't matter that much. Like the efficiency scale is really.
Yeah, that's the trouble that I've had trying to figure out. It's like I can't put a finger on why do I feel like lower pitch props just feel like they have better fine control.
And they do because they're just slightly tuned towards a lower RPM, which means that in those lower RPM ranges, they're not like he was talking about. They're not going to stall, and so you're or not stall as much. So that when you're going around a gate or you're trying to do some very fine-tuned maneuver, you're not like going balls out speed. Then you're going to have more control. It's you're not going to be stalled as much. You're going to have more grip in the air, stuff like that.
That makes total sense. So my theory was totally wrong. That's great. That actually does make a lot more sense. Wow. So then prop design actually does have more of an influence than I expected. Interesting.
The thing with the higher KV, or not higher KV, but the higher pitch props is that you need more torque to really be able to spin higher. And so those wider stator motors, some of those Rebels that are like 2507. I helped a guy tune a 2507 on a floss frame or something like that. Yeah. And he's running a Helio board. He posted a picture of it, and you have to turn down Q quite a bit in order to just control the amount of torque that this thing puts out. Otherwise, you'll just wobble in midair.
Yeah, that's that's why a lot of freestyle pilots prefer using lower powered motors, because they're just easier to handle, easier to manage.
They're more fluid.
Yeah.
Yeah, I mean, I use 2800 kV 1407s on my 3-inch build, like super low. It don't have a good top end, but I'm not racing, so I don't need that top end. It flows beautifully though,
Yeah, I like making really crazy high powered quads just just for grins and giggles. And so, like, I built that Mach 1 and a floss on some pretty high power, high kV motors, and yeah, they're not easy to tune. And before I stuck these the new boards we just made on them, they were almost impossible to tune. You had to try to use TPA to control a lot of the oscillations at high throttle and stuff, and this has just fixed that.
So is that why 6 inches is so then if you put 6-inch props on like a smaller motor, 2207, 2206, it would actually not be that hard to tune. But once you get up in the torque, then it's going to become a pain.
I would say when you get into the higher torque for the size of frame, because there's not as much mass to
that makes sense.
absorb that.
Right. Oh, that's a good other question. Do you guys know what a custom mix is for like motor layout?
Yeah.
Like custom mix.
Yeah. What about
it? Does that have any value in terms of ButterFlight or any of the control systems?
Not with a PID controller, it doesn't, because basically he will end up doing the same thing. Well, he won't. I will, I guess. But so if you make small changes to try to adjust the frame, it'll end up being made up for in the PID controller anyway. You'd need to make large changes correctly. For example, a hex is obviously going to have a different mixer. But as far as, frame width and changing the mixer, I've played with it, and honestly, just adjusting your P ends up being the same thing. Your ratios to the PID controller, I should say. For example, if you have a quad that's 20% longer than it is wide, if you change your P 20%, it's going to end up being the same thing.
Okay, so then it just requires a different tune, and then it's pretty much the same.
Yeah, on your narrow axis, or whatever your narrowest axis is, you're going to end up with a closer ratio of P to D, because it doesn't have to move as far, and it needs to be able to stop it. Because it's just like if you're, a dancer doing spins, they go in and pull their legs in, right, and they're going fast, and they put it out a little slower.
Yeah.
So you end up with a little bit lower P
and ultimately, that's something I think Chad Nowak touched on that in one of his live streams. Even he mentioned he doesn't change the PIDs as much as he kind of just slightly tweaks his rates a little bit. And
that's what I do too.
The difference between stretched wide or true X kind of plays itself out. And even when it comes to like awkward configurations like plus quads, it's just the same thing. You have a different effect on like how much work like each motor's doing slightly, but from the PID controller standpoint, it doesn't really care. It needs to know where those motors are geometrically, but that's about it. I mean, you got to think about it like this way. You have 3 axes that you operate on for your PID controller, pitch, roll, and yaw. However, once that value comes out for an axis for what the PID sum is, because it just adds up the sum and that's what goes out. That gets thrown into the mixer, which says, all right, well, I know how much I need to do on this axis, but which motors does that go to and by how much? So just changing up your configuration from an X to a plus or anything like that, it's just going to kind of change the math of how that works. But otherwise, like, it's a similar control.
Yeah, the mixer is actually more. There's more algebra inside of the mixer than there is in filtering.
Yes, the mixer takes longer to run than a lot of these filters. It's interesting.
Oh, so then you don't even want to have any custom anything. Just leave it standard. It's preferred.
Well, I mean, there's not really like any added difference from going to like an X to a plus for the mixer.
Yeah, sure.
It's the same amount of work for the CPU to actually do it. It's just different.
Yeah, exactly.
Oh, one last thing I forgot to ask too. The Helios board, the F3 plus F4 combo, is it kind of negates the need for an F7.
It's faster than an F7. In fact, I
Okay.
believe it's actually faster than the H7 when you consider the real-time applications.
Would you ever move to 2F4s?
It's been discussed, but we don't have the need for it at the moment. Maybe
How taxed is
in
the
the future.
system right now?
We still have quite a bit of overhead if we need it.
Yeah. This is something that I loved when these guys first kind of told me about this. Again, my background is both mobile as well as like back-end data processing on a large scale, and that's something that I have a lot of experience with is scaling itself. Scaling an amount of work, whether it be scaling it up or scaling it down for mobile applications. The approach that they're taking is literally it's horizontal scaling. If you ever want to
Right,
take a look
yeah.
at different scaling theories, there's vertical scaling and horizontal scaling. Going up to like an F7 or an H7 is vertical scaling. You're just adding, you're getting a bigger server, if you will. So for the web server analogy, you need to handle more requests. You get a bigger server. Your bigger server handles more requests.
Yeah.
Whereas the F4 plus F3 approach is horizontal scaling. You offload, you split up your responsibilities of tasks, and or you just you load balance or whatever. But you, instead of getting a bigger server, you get a second small server. And there's debates over which is better for what application. Horizontal scaling is in a server world is pretty infinite because you can add as many servers as you want. You
Right.
can't add as many F3s on a flight controller as you want, though. You do run out of space. But nonetheless, that's what it is. You're offloading that work from that core loop, and you're putting it onto a dedicated processor. So in the end, both of those processors are a little bit happier at the end of the day because they're not doing nearly as much work as just one would be doing for all of it.
Yeah, you can
So-
run on the F4. You can run a 32K gyro and 32K PID loop with our on the Helio board at 20% CPU, 20-21% with the accelerator on the rack.
So how far in the foreseeable future would you assume or guess that this combination would support? Like a year, 2 years? What's the guess, at least? The
What do you
best assumption.
support? What? Like how
Before you need to increase power or do something else to, get some more abilities.
need or want? Because
Both.
there's a lot of stuff we want to
Or
be
you
able
want.
to do. And there's a lot of stuff that you really can do with this without increasing costs. So in my career as a software architect, software engineer, it's how do we adjust things in such a way that it doesn't increase costs for the consumer? Because sure, we could throw a Snapdragon or something on the board, and it would cost $26 more than what you're spending now, and people would, well, what the hell is wrong with you? This is dumb.
But hey, you got LTE now, right?
What we want to do is say, okay, how do we make the minimum amount of change with the biggest amount of impact? And the easiest way to be able to do that was what we did. Was to be able to say, what's the smallest package that we can fit on the same size board? What is it that we can offload without drastically changing the way the software continues to work as it is now, and create this better ecosystem of hey, we have this technology which makes everything run better, and now you have more room for other features like return to home, navigation, whatever else you can possibly think of to do with a quad, autonomous flight even on the same hardware. Automatic, PID controllers or whatever it is that the developers want to do. They were stuck in this year-long rut of, well, how do we fix filtering? How do we fix filtering? It needs to fly better. Well, now you don't have to worry about that. Now you can say, hey, filtering's fixed. How do we move forward and advance this so that it's more accessible to other people and easier to use and expand the entire market?
Mm-hmm. This is amazing. This has been an amazing discussion. So eye-opening and so informative across the board. I didn't give you guys a great introduction at the beginning because I don't know how many people actually pay attention to all the actual developers, but you've clearly presented yourselves thoroughly. I'm sure everybody has heard all of your expertise and what you guys are doing. and appreciates it very much because like BetaFlight's kind of like a faceless group that nobody really knows, and it's very nice to have you guys interacting with the community and just listening, getting feedback, anything, just any kind of interaction with the community because nobody else does. None of the other flight groups actually. I don't see people posting around on Facebook from other flight groups. Hugely, hugely, hugely appreciated. That alone is enough for me to be 100% on board because you guys are so proactive and responsive. So thank you so much for that.
Yeah, not a problem. I think one thing I kind of like to look back on is, I used to write iPhone software for jailbroken iPhones, and one of the things I guess that gave me experience for was being able to field, 20,000 requests in email form from users that have a bug, because that's the kind of scale that I would be looking at. Mm-hmm. So, I think coming to BetaFlight, it's actually comforting that knowing that the community and the user base is just, I don't want to say smaller. I don't want to encourage it being small, but it means it means I can be more hands-on and more interactive. I can ask people questions. I can get feedback a lot easier than just having 30,000 people email me one night saying, "Hey, there's a bug. I paid for this. Fix it now."
Oh yeah, that's the other thing. So do the flight controllers have serial numbers? Like, does it linked online?
So that's part of our. What do you mean the flight controllers from Helio?
Yeah, so when you plug it into the configurator, does it have a name for each controller, each board, each actual board? Can you identify each actual board?
We can. There's no real way for anyone else to tell right now.
Every STM32 processor has a unique serial number on it that you can look up by plugging it in DFU mode and running DFU util.
So
then
the F3 is sitting behind the F4. So unless you do some micro soldering and actually like connect up an STM link and all that crap, it's pretty transparent to the F4, and so you won't be able to see that, but we will be able to through some of the stuff that we're going to be implementing. But we also keep track of all of the chips that have been flashed, similar to BL 32, right? Like the only way that things are gonna get better is if people say, okay, well here's something that we've done which is better, but we also want to help the community, instead of like trying to keep it all for ourselves. Like, hey, we've done something better. We don't want to break anyone's bank, but we should also get paid for the amount of time we spent on it.
Yeah.
So,
it's a very nice method you guys have figured out, which with the custom hardware and the unique code on the custom hardware. I think it's a very, very nice compromise.
Yeah, the balance of open and closed source is very nice here.
Yeah.
Both have their merits and both have their pitfalls. I've worked at a few pretty big companies now, and I can say that one of the trademarks of any good company is having a good balance between that. I mean, if you look at Facebook, Google, any big tech company right now, they have good open source software out. They've contributed back to the community. There's a few big names that haven't, and they're the ones people like less to use. One of them shares a name with a type of thing you would have on your wall to look outside, nonetheless.
A porthole?
Sure, yeah, portholes.
So the other thing I've recently been talking to Fox here about is that I told them they should start considering putting what's it called, UARTs on their cameras so that we can put our own custom firmware for the cameras on board and hopefully have it be controlled by the flight controller, at least programmed through the flight controller. Have you guys considered anything like that, or any kind of camera firmware from somewhere?
Let's just say there's going to be some stuff that comes out from Helio, assuming that we don't like completely destroy our own company. But assuming that we do a good job and you guys like it, and that we can continue to improve on stuff, there's going to be some stuff that comes out of us that is going to change this industry, change everything that you think you know about quads and think you know about flying in general.
I
So
think
Incredible.
one of the things specifically about like cameras, I know people have batted around the idea before of asking Run Camera Fox here to put OSDs on the camera. Well, there already is an OSD chip, but providing firmware access and a UART to it. One thing to consider with that is the reason BetaFlight OSD moved to built-in OSDs on boards using SPI is speed. UART just does not have the transfer speed that is nice for a good OSD. But there's a lot of other things that can happen. I mean, it's certainly fine. I think even like F7 chips can do all of the functionality of an OSD, if I'm not mistaken.
Oh, right. Yeah, I've seen that.
So there's a lot of different things that can be done with the hardware we have. And one of the things I mentioned to Kalyn and Tim last night was even motion coprocessors have been around since 2013, since Apple decided to bring them to the market. Imagine if we had entire systems on a chip, like Tim mentioned, if we had full Snapdragon SoCs for our flight controllers. Those things are technically doable. They're beyond the reach of a lot of us in this community for a lot of reasons, price or interest or
scalability.
Exactly. So, but yeah, I mean, nonetheless, tech exists. It's a matter of how do we figure out how to make it work right.
I will throw this out. I think virtual reality is a sham. I think augmented reality is the holy grail of where this is going, and that's what I'll say.
We've been it's over an hour. I don't even know if people will listen to it for more than an hour, but it's just amazing. I mean, thanks to you guys so much. I cannot wait to see where these things go. It's, I mean, how much farther do we have to go before like the whole world takes notice and they're like, holy crap, yeah, we want this too. Okay.
I mean, keep in mind too. I think one of the things people, we are still flying toys, and unless we can make other people want to like our toys, then we have to make sure that if we're going to make something, we should make it applicable outside of just, again, our toys.
It's so hard to understand that people are not interested when you're interested. It's so difficult.
There's something too. The reason is that we named the board Spring is we originally were thinking about ways to bring this to everyone, right? Because like the hobby's awesome, it's cool, the community's great. There's a lot of great people there, all willing to help each other out. And but when it comes to businesses and making money and everything, like the hobby's only so big, and we wanted to springboard our way out of into other markets, into the commercial area, because the stuff that we're creating is more applicable applicable to more than just us, more than just the hobby. It can really improve a lot of things.
Yeah, absolutely. I mean, it's when are you guys going to the moon? Like, when are you sending something to the moon?
Sounds like it'd be a lot of fun, actually.
I bet we could actually. Well, go ahead.
I'll just call up Elon Musk.
No, the thing is that I'm surprised that there isn't like a hobbyist group that maybe there are. There are people trying to like go to the moon and come back.
There's a lot of legal things around the rocket fuel required.
Legal things.
Yeah, and there are groups that try to do that. There are people who have actually sent themselves into low orbit, but they're also
I've seen those.
Like Elon Musk, who sends his car out into space.
Which, by the way, a lot of people are angry about that. Like, there's actual angry figures, like public figures, that are saying, why would you put a car out in space? Like, it's such a waste.
Because
put, like,
awesome.
High school students science projects. It's the most ridiculous things I've heard, and they should have just used. They said that it would have been better had they used a dummy weight, which they should have done, which other rocket companies have done in the past. They just put a concrete slab in the
yeah, that's what
shuttle.
typically is done with test launches for weight simulation. But
he put his car in there, and people got angry. What?
It's for science.
It's
concrete
though.
And you read the article about it, and they're like, there's almost no chance of the car coming back around and running into the Earth.
We know the effects of concrete in space. We want to know the effects of a Tesla in space.
I want to see the flyby of the car in like a year when it comes around.
I want to see in like 20 years it's still going around and someone actually does put another car up there, but they're actually driving around and seeing this crappy Tesla that's still there.
Well, you know, that's a this is completely off topic now, but that's a problem with that's a theoretical or I guess a philosophical problem with space travel, traveling to separate solar systems and whatnot, is that there's a point going to be a point in history in which we have the capability to launch people to another star. However, the journey will take them forever. And there's an ironic kind of like point in history after that where we develop faster space travel, and those people that are much, much younger pass the first people that left.
Yeah.
And they'll all be using Kalman filters.
or we'll just find Stargate rings all over the planet and we'll be set.
To be fair, once we figure out warp, we don't need to worry about motion because there's no motion with warp drives. You just change how space works and stay still pretty much.
We don't care about flight controllers. We're just going to make flight controllers work the way we want them to.
Okay, I'm gonna stop it here. But thank you guys so much for coming. I could not thank you guys. It was amazing having you guys. Just talking to you guys.
Thanks for having us.
Yeah, thanks so much. I'm so much looking forward to what's coming.